Hello and welcome to the lecture series on Introduction to Measurement. I am Dr. Madhumita Das, Assistant Professor AEIE Department, Haldia Institute of Technology, who delivered the lecture on Introduction to Measurement. This is the module number 1, and this is the basics of measurement, where we will have to learn that what are the different terms associated with the measurement techniques. And generally these measurement techniques is that is applied in instruments, and in the instruments that the different types of parameters to acquire the results or the data, and depending on the data collection, what are the different data parameters. So these different topics will be dealt in the introduction to measurement. The topics are the methods of measurement, measurement system, classification of instruments, definition of accuracy, precision, resolution, speed of response, errors in measurement, classification of errors, the different types of loading effect due to shunt and series connected instruments. So these topics will be generally covered in this particular module. When we are talking of measurement, that means one measurement technique, one measurement parameter, or one particular measurement of data is to be related with the standard values. So that particular, if we are going to measure a particular parameter, so that particular parameter has to be classified or has to be compared with the different types of data which are actually taken in standards. So measurement technique, this is in comparison between a standard and what we want to measure. So what we want to measure, that is generally termed as the measurand. So the two quantities that are compared, the result are expressed in a numerical values. So when we are going to compare a particular value that we are taken as a measurement parameter, that has to be compared with the standard value, and how much error is there in that particular value, we need to calculate the error and different other parameters. The basic requirements for a meaningful measurement are: the standard used for comparison purpose must be accurately defined and should be commonly accepted. The apparatus used and the method adopted must be probable. Whatever the methods that we are going to apply, that methods along with the apparatus will be discussed here. The two major functions of all the branches of engineering are that we are going to, as an instrumentation engineer, we are going to design the different types of instruments, and when we are going to design a particular instrument, we need to know the different types of parameters associated with the different types of instruments. So basically the design of the equipment, the process that is involved, the proper operation and the maintenance of the equipment and processes, all are related to each other in this particular branch of engineering, that is the measurement. So different types of methods of measurement that are classified, generally classified as: one is the direct method and another one is the indirect method. So in direct method, what we have is that in this methods, the unknown quantity is directly compared with the standard. For instance, when we are going to measure current, when we are going to measure voltage, so that particular current and voltage is direct measured component or direct measured parameters. So these type of methods in wherein we measure current, voltage, etc., those are classified as a direct method. However, there is another method, that is the indirect method. In indirect method, measurement by direct methods are not always possible. So it is feasible, it is also not feasible always, like that of current measurement and voltage measurement. In engineering applications, we need to measure that different types of indirect method, like when we are going to measure a resistance. So when we are going to measure a resistance, we can measure the voltage, we can measure the current, and then we can accumulate that what is the value of the resistance, that is using Ohm's law, that is R is equal to V by I. So measuring a resistance comes in an indirect method, whereas measurement of current and voltage comes in the direct method. there is coming to the evolution of instruments. We use generally different types of instruments like mechanical instrument, electrical instruments and electronic instruments. So basically these evolution from the mechanical instrument to electrical and electronic instrument comprises basically of mainly a particular parameter, that is the speed of response. So when we are going for mechanical instrument, these instruments are very reliable for static and stable conditions, but their disadvantages is that they are unable to respond rapidly to measurements of dynamic and transient conditions. So any type of mechanical instrument cannot record any type of transient conditions parameters. So for that we need electrical and electronic instruments. So these electrical and electronic instruments, they are very rapidly respond to the measurement part. So so in electrical it is faster. In electrical instruments, the electrical instruments are faster than mechanical instruments, which are the indicating the output as rapid as 0.5 seconds to 24 seconds. However, we again needed more reliable and more faster instruments, that is the electronic instruments. So electronic instruments from that of the as compared to that of the electrical instruments, it is more reliable than other system. It uses semiconductor devices and weak signal can also be detected using electronic instruments. Next, we are moving to the classification of instruments. In the classification of instruments, we are generally working with absolute instruments, secondary instruments. The absolute instruments are the instruments that give magnitude if the quantity under measurement in terms of physical constants of the instrument, whereas in secondary instruments, these instruments are calibrated by the comparison with the absolute instruments which have already been calibrated. So basically these type of absolute instruments are that which quantify the exact or some physical constants of the instrument, but secondary instruments, these instruments are actually calibrated with respect to these absolute instruments. So basically in general in our day-to-day work environment, we generally work with this secondary type of instruments. Further, these type of instruments is also classified as deflection type of instrument and null type of instruments. The functions and the instruments of measuring system classified is also as indicating function or recording function or controlling function. So these different types of functions are also included in the measurement part. We will deal all these in module number 2. And in here, this is a particular block diagram, is a basic functional block elements of an instrumentation system. So basically an instrumentation system, what it comprises of many types of blocks which actually functions as a whole instrument. So the primarily there are different types of blocks over here. So the first, when we are giving input to a particular instrument, so that particular measured parameter or the measuring has to be given input in the primary sensing element. So these primary sensing elements, so with respect to in this primary sensing element, the first the measurement parameter comes in, and after this is primarily the sensing part. So in this sensing part, different types of sensors are involved, and once the sensor data is been converted to given into input as a variable conversion element. So in this variable conversion element, we have different types of other parameters, like if we get very low voltage, so that voltage has to be modified according to our design parameters. So after this block, we have a variable manipulation element. So these different types of manipulating functions has to be done in this particular block. After that, we have data transmission element, and then we have data presentation element. So functionally, when a particular data is given input to the primary sensing element, then traveling through these particular blocks, finally the data presentation blocks come in. So we have a detector transducer stage, this is the primary stage. We have an intermediate stage. This intermediate stage comprises of variable conversion element, variable manipulation element, data transmission element, and this is the particular data conditioning element, and after that the data presentation element comes in a terminating stage. So any type of instrumentation has any type of instrumentation system has these entire blocks. So over here, this is the general descriptions of all these types. What are the different functions of these particular elemental blocks. Now the static characteristics of instruments and measurement systems. Basically, these static characteristics comes as accuracy, drift, dead zone, static error, sensitivity, reproducibility. All these comes along with the precision. So these are the different types of static characteristics of an instrument. So these are also, so accuracy. First one is accuracy. It is the closeness with an instrument reading approaches the true value of the quantity being measured. So this true value is nothing but the true value of a quantity can be defined as the average of infinite number of measured value. The sensitivity is defined as the ratio of the magnitude of the output response to that of the input response. These are the different characteristics. Static error. So when we are going to define static error or find static error for an instrument, it is defined as the difference between the measured value and the true value of the quantity. So if we consider that AM is the measured value of the quantity and AT is the true value of the quantity, so AM minus AT gives the static error of a particular device. It is also sometimes known as absolute static error. So when we are working with the different instrument, there comes the scale range and scale span. So once a particular device is there, then we have a minimum value and maximum value. So in the minimum value and the maximum value, this becomes the scale range, and the scale span it becomes the maximum value minus the minimum value. We have reproducibility. It is specified in terms of scale reading over a given period of time, whereas drift is known as an undesirable quantity in industrial instruments because it is rarely apparent and cannot be maintained. So this drift, which is an undesirable quantity, it is also classified as zero drift, span drift or sensitivity drift, and also zonal drift. Here we have a picture where it shows the zero drift. This is the zero drift, this is the actual value, and this is the zero drift. This is the span drift. We can see the span drift over here, and this is a combined effect of this zero drift and the span drift. So these are the different types of drift. Apart from the static characteristics, what we have dynamic characteristics of measurement system. It is the speed of response, the measuring lag, fidelity, and the dynamic error. Speed of response is defined as the rapidity with which a measurement system responds to changes in measured quantity. It is one of the dynamic characteristics of the measurement system. Fidelity, it is defined as the degree to which a measurement system indicates changes in measured quantity without any type of dynamic error. Dynamic error is the difference between the true value of the quantity changing with time and the value indicated by the measurement system if no static error is assumed. It is also called measurement error. It is one of the dynamic characteristics. We have measuring lag or measurement lag. It is the retardation or the delay in the response of a measurement system to changes in the measured quantity. It is of two types, the retardation type and the time delay type. In the retardation type, the response begins immediately after a change in the measured quantity has occurred. However, in time delay, the response of a measurement system begins after a dead zone after the application of the input. Now coming to the different types of errors in measurement, we have a different classification as gross error, the systematic or the cumulative error, the random or the residual or the accidental error. The systematic error has been also been classified as instrumentational error, environmental error, or the observational error. So in the gross error, what we have is that there are different kind of human mistakes can be done while reading a particular data from an instrument, and also this can be done. This can happen in recording of a particular data or calculating of some measurement results. So, for example, like due to an oversight, instead of 21.5 degrees centigrade, one may read as 31.5 degrees centigrade. So, this kind of reading, like 25.8 degrees centigrade, this can also become while taking the reading or taking the recording, it might become 28.5 degrees centigrade. So, these are classified in gross errors. We have also systematic errors. And instrumentational error, environmental error, and observational error are the classification of the instrumentational errors. These the instrumentational errors are generally due to some reasons. These reasons are due to inherent shortcomings in the instrument, due to misuse of the instrument, due to loading effect of the instrument, and also the environmental error. These errors are due to condition external to the measuring device. These may be effect of temperature, pressure, humidity, dust, or some external other electrostatic forces or magnetic fields. Observational error. The error on the account of parallax is known as the observational error. Residual error. The residual error are due to the multitude of small factors which change or fluctuate from one measurement to another. So, these are known as residual error. The happenings or the disturbances about which we are unaware and are lumped together are called random or residual error. So, these errors are very much fluctuating from one particular instrument to another particular reading, another particular measurement. These can differ. So coming to when we are accumulating different types of data, n number of data, so we may have to find out that what is the arithmetic mean of the data, the deviation of the data, the standard deviation of the data. So these are will be discussed here. So in the arithmetic mean, if we have n number of readings, this is the formula for arithmetic mean. The most probable value of the measured variable is the arithmetic mean of a number of readings taken. So it is given as x bar is equal to x1 plus x2 plus up to xn and divided by n. So by this particular equation we can calculate the arithmetic mean of a number of data, n number of data. Then from this, deviation is the departure of the observed reading from the arithmetic mean of the group of readings. So there are n number of readings, we have some deviations from the mean. So we will calculate the d1, d2, d3, d up to dn. These will be the deviations of the instrument and reading. So this is the formula for the standard deviation. So we have to also calculate the different types of standard deviations of the data. So standard deviations for greater than 20 observations, we have this particular formula, that is standard deviation is equal to sigma root over of summation of d square by n, and standard deviation when let us suppose we have 10 number of observations. So we have SD is denoted as, standard deviation is denoted as S, and that is root over of summation of d square by n minus 1. We have variance. This is the formula for the variance for greater than 20 observations, and this is for the less than 20 observations. So we can calculate for n number of observations also the probable error. So coming to the calibration part, after doing these type of measurements, we must know that when we are going to measure, that means we want to measure a particular data with respect to a standard one. So calibration is a very important factor in instrumentation. So calibration of all instrument is important, and since it affords the opportunity to check the instruments against a known standard and subsequently to find the errors and the accuracy. So this is a primary standard. This is the primary standard, and with respect to the primary standard, these are generally given by the output from the absolute instruments, and these are basically the functions where the secondary standard comes in. So the secondary standard with a higher accuracy than that of the instrument to be calibrated, and instrument of known accuracy. So that means calibration means we are going to find out the different types of errors that is occurring a particular instrument over a period of time. So over a period of time, any kind of instrument has to be calibrated. There are different standards. Standard is a physical representation of a unit of measurement. The term standard is applied to a piece of equipment having a known measure of physical quantity. There are different types of standards, some international standards, primary standards, secondary standards, and also working standards. Thank you.